Okay, so this became the index column now. Okay, now say you want to access first 5 rows. Okay, first 5 rows. Dot ilock. Okay, dot ilock
0:5.
5. Okay, it's the same as 0:5. So it will give you access to. So there is the important thing, ilock. Ilock means it will access by index. Similar thing you have with lock, but there you will be accessing by values. If I mention it lock here, right? I mentioned here 1:5. Okay, it will access by see one it does okay one it takes this value. Okay, and 5 will be 5 here is included. Did you notice this? Lock. Huh? So you want 2 ways to access it, because sometimes you want some like name column you want to make index. Got it, right? You want to make name column, then you cannot say sometimes your employee ID or say ticket number, you want to make ticket number as index. Okay, set index and ticket, and you have to mention in place is equal to true. Okay, then you see this Titanic data head, you see ticket became index. Okay, in this case you cannot use you want to use, okay, I want to access all the data between this value and this value.
So, what is in place when you set it to true? What does it mean?
In place means it will set index. If you don't do index, it will return a new data frame whose index is this. It will not alter the existing data frame. When you use the set it in place is also true, it will convert the existing data frames.
Whatever existing indexing was there, replace that.
Okay. Did you mean like
in place? I mean replace that this data structure itself.
So if you don't make it, if you don't set it to be true, so what will be the output then?
If you don't set it to be true, the output will be it will return a new data frame, but the Titanic data will not be updated.
Okay. Okay, it will return, but the update will not be happening.
When you say it is updating, that means is that updating in the source or?
Updating in the source.
No, source means in the CSV or?
No, CSV is out of picture on the data frame. It's just saying completing there is non-unique label. Okay, that is a slicing.
There's more numbers than this.
So the more numbers, it's not unique. So I cannot slice it based on that. It's confused. Where do I slice it? But like in our earlier case, if I again change, just load the data once. So I'll show another example with not. There is one data with movies. Let me just show. That is the better example. this file. This is JSON file. Raw. PD dot read JSON. Can you see this data? What is the index? Index is movie's name, and these are rating. These are like the different director, I guess, director or different person who is giving the rating. Got it, right? This is a movies file, movies data frame. Now, what you want to do? And this is a good example to show log. Movies dot log. First, let's see the content. Movies dot log. Okay. In case of lock, you have this is the starting point. See, lock means you are accessing not based on index but the values of the index, not index number but the values. So what you can do, you can pass here from this point to this point.
I love is the indexing and lock is the access.
So if you do the same thing with iLog, all right, it means 3, 4, 5, 6 will be excluded. Whereas in previous iLog, the apartment is included. Okay, so whenever you want to access by values and all that, you can do this. And the more important thing here is movies.
From the lock also, the question is based on indexing, right?
I mean in index column only, but you're passing in index numbers, not the index values. Oh, log, you're passing here index values.
The values, but what is the order? Already it is forming some order. From that it is picking
Right.
So that order is same.
Same. Right. Just that it is using values. Log. I means index. Okay, this being. Okay, now if you do this, you want all the movies in which Adam Cohen has rated more than 1. Right? If I ask you that, so you can. Movies. Then. Did you see this? So this is a basic filter operation that you are doing here.
Pandas is mostly for filters.
No, it is mostly for data ranking, data getting. There are a lot of operation, join operation you can do. Okay, so that's what. So you can.
Whatever operation we are doing in an access, is that possible to do in Panda? Like multiple VLOOKUP.
Multiple view lookups. Yes, you can do that.
Chart.
Yes. All the things. If there is something you might use very often, so there will be easy documentation. If there's something, there might be another way to do it, but we can do everything. See, here you are adding a simple filter, right? Also, you want to add a little complex filter now.
Now can you add indexing?
Here.
That the index values.
Actually, so here, if I just copy, if I just execute this part, right? So just execute this part. It will return you a boolean. Not a red boolean. So this is boolean array. So if you pass this boolean array to this movies, it will return you all the data for which it is true. Got it, right? So if I So here, see here anyway, this is the filtering condition. You can see here. Column, this is a column greater than this, the filtering condition. So here, there is no point having iLock or something like that. Here you can add one more filter condition definitely, like for a David Smith.
So, so instead of the column wise, so instead of this movie's David Smith, can I add like this colon 1:2 or 1:3? So I need data only for first 3 rows. I can incorporate that.
Yeah, no, but not this day. You want first 4 rows.
First 4 rows.
On that you want to do. On that you want to put
yeah.
this check, right? On first 4 rows you want to put this check, right?
Yeah.
So what you can do is, movies iLock first 4. After that you. Alright, this will return a data frame. This is the first 4 data frame. On top of that, got it, right? Filtering, you are cascading different things.
This data frame is a variable. This data frame is a variable. Like integer.
It's a data frame. Your type, it's a data type.
It's a data type.
Okay, data type. So it data type and it has a lot of functionalities. Okay, so you understood how to access data, right? Lock, iLock, put basic filters. If I give you some questions, you can pick certain information out of it. Then you have things like IAT. Movies. IAT means third row, fourth column. So it is returning you third row, fourth column value by index. Another option you have movies.at. So, got it, right? Yeah, one is IAT. IAT means you will be passing by index. Another is AT, you will be passing by values. So these are how you access it. These are how you filter it. Okay. Now let's deal with some joining operations. Okay, what are various steps of joining and all that. So let's create a data frame. You have DF1 and DF2. You want to stack it on top of one another. PD concat DF1. Right, and once you do that, you see that the index number repeated. Okay, so you have to pass one more parameter, ignore index 2, so that the index number is retained. So this is how you actually create two. Suppose you have a 2 data frame or 2 files or daily report, right? You can imagine sales daily report is almost the same schema, but you have to combine daily report to create a weekly report. You have to combine all these values.
The holding is bound with the same index. Huh? Data system. User report the user index report. Before the how same index.
Yeah, index is not something which ensures that it will be unique. Okay, you might not be able to do some operations, but there is no mandate that it will be unique. That's all.
So now can you please scroll up?
Fine, right? So you have 2 data frames. If you want to combine them together, like imagine this as daily sales data. You can combine them like daily 7 days sales data to a weekly data. Combine the weekly data to monthly data to yearly data. Right? You will do this sort of operation.
So okay, data is not. I mean, if the data is like duplicated, it's not eliminated.
Fine. Now, yeah. So this is the first API concat where you are actually appending 2 data frames on top of one.
It is trying to concat column wise. Is there a possibility to make it row wise?
What do you think? What do you think? Should there be one or
there would be one?
So this is the one. Okay, all you do is you just pass the access information. Got it, right? So the important thing to understand is, as we discussed earlier, what is access 0? Yeah, horizontal access. Opposite. This is access 1, that is access 0.
Okay. So then ignore index, right? So what operation it is doing?
It is actually, if you don't ignore index, it will use the existing index of the data frame. That means without ignore index, what was happening? See, without ignore 0 to 4 and 0 to 4.
Okay.
Okay. And so you need to make sure it generates the right index.
Okay.
Okay, and if you do access, you can see here column name also needn't be same, unique. Okay, of course you'd want it to be unique so that you can seamlessly access it, but that's all the cases, and you can mention access is equal to 1. So there's column wise addition. Understood, right? So concat is for appending information, appending rows, appending columns, right?
Here if you want to duplicates.
I'll get that. Handling duplicates. Okay, let's first see join. Then you, after concat, you have another useful utility, that is your merge. Merge is more of a database style. It can do this, finding. I mean, merge typically works as 1 to 1, many to many. All those things it can do 1 to many, right? So let's create a data frame.
Sir, I have a question. So when you said access is equal to 0, so is it like almost same as this ignore index?
No. Access is equal to 0 means access is equal to 0 means that is by default. It means column wise operation.
Column wise.
Access is equal to 1 means row wise.
Row wise.
So this is data frame 3. This is the above is data frame 2, 2, 3, 4, 5, 6. This is data frame 3. It also has a B column. 2, 3, 4, 5. Okay, so here you have B. Here we have C. Okay, and you also have 5 with 44. Right, so you have DF1 and you have DF3. Okay, so now if you do DF1, got it, right? So what it will do, it will just use default. I mean, in by default, it will find the column feature of same name. Okay, so it is using B column to combine them. Understood, right? It is using B column to combine them, and it is combined this DF1 and DF2. You can see, you can change the order also. Like you want to make it 6, make it 5. See, it actually makes sure. Like 5 was 88, right? 5 was 88, and 5 was 6. Got it, right? So here 5. No. This is DF1. DF1 5 is how much? 6. DF3 5 is how much? 88. Am I seeing something wrong?
No, sir, it's correct.
Correct, huh?
Yeah, it's correct. So it is mapping for 5, right? 88, and for 5, A is 4. So, and for the index.
Oh yeah, I was checking here.
Yeah.
Right. Yeah. No, yeah. So here, this does not matter anyway. So for 5, it is 4.
Yeah.
Okay. And for 5 here, it is 88.
Is 88.
So 5, 4, and 88. Right. So that's what it actually is doing. Okay. See here, it is 5, 4, and 5, 88. So 4 and 88. Understood, right? This is basic join operation. Of course, you can actually play around it a little bit. Like, you needn't have same column name here. You needn't have same column name here. You can give it B1. Okay, now if you do df1 dot merge df3 by the parameter.
It's trying to find the common elements in.
No. It needs a. I think we're on. But it does it. It needs a. So how? I think how it should be. B1. Sorry. No common column. So what it should do, you need to tell it explicitly that which columns you want to merge it on. Now the two data frames are the df1 and df3, both have different schema. df1 is this and df3 is this. Got it, right? Both are different. You want to combine b and b1.
We can do it by index.
Left, huh? No, not index. Here merge itself, there is one parameter here. So df1, so I think left on, not on, left on. Left on, what is the df3 left on is b1, right? And you have right on it is b. Now can you see this? It combined based on b and b1. See, values are same here. You notice this? And of course, after doing this entire operation, you can drop. B1. B1. Right, it dropped this B column. Is it clear?
I know the value is same, but the order not same. But if the value is also not same.
No, what I did here, see, you have DF3, right? This is your DF3. This is your DF3. Okay, and you want to combine DF1 and DF3 based on the values of B and B1.
Which are same in B.
Though values are same, but the column names are different. Okay, so that's why you have to write left on and right on. Okay, for left data frame you are using B1 column, on right data frame you are using B column. After that, you get your output has two additional columns. One is B and B1. You want to drop B1
because they are same.
So, say suppose I don't want to drop and I just want to merge. Okay, so is this like when I have to merge like two data frames? So should we always specify left on, right on, or is there any other way we can just merge, even though the columns are duplicate with different column names?
No, merging means what? Based on certain values, it will connect.
Yeah,
right?
yeah.
So you have to tell it explicitly.
Yeah.
If you're not telling it, it will rely on like earlier we did. Same column name it should have.
So I'm asking. So in that case, so is this the only way? So whenever we want to merge two different data frames, right? So should we always specify left on, right on, or is there any other ways we can merge?
A lot of other ways. Also.
Other way, yeah.
You can merge by indexes and many more things. Is it clear what is this left on, right on? Okay, of course, what you'll see now is a little. Sometimes.
Sir, I still did not understand this left on, right on actually.
So see, when you are combining two tables, you need one column in common so that you can combine those values,
exactly.
Right? Okay. So here, when you are combining this table DF1 and DF3, the column based on which you want to combine is B1 from table 2 and B from table 1. Alright, so we have to explicitly mention that use these columns to combine values.
Okay.
Yeah.
It is actually the joining.
Database join.
Yeah.
Complex join. If you wanted to select some data between two tables.
Yes.
But based on what you will be selecting.
Yeah.
So join, you need to give some conditions. You need to equate some common column.
Exactly.
So it is the same like that.
Yeah.
Absolutely.
Just a little bit syntax is different, but the same.
Absolutely. Now, okay, so which is 6 and 99. So you can see here DF3 is a new data frame. Okay, this DF3 is a new data frame which has some additional values. Okay, so of course, if I do DF1 join merge DF3 left on right. So you can see here this last value is not coming in picture 99 because it's not there in both the tables, right? So by default this is inner join. Got it, right?
It's not common that it is dropping.
That is inner join. This is database. All are comfortable with database things, right? So database you have inner join, outer join, left outer join, right outer join, and all that. Okay, you're not right. You're comfortable, right? Okay. So here you are telling here that you have left on and right on. You are using B and B1 column. right? And I'm doing so, you can see the last row is eliminated here. That is because by default it is inner join. So if you do outer join, you can see NANs coming here. Okay, this is your merge utility. Now, having said that, you have based on index also. Sometimes you want to combine data frame based on index. Okay, last thing in it, pd dot. Two, three, four, five. Six, 7, 8, 9. Okay, so you have this data frame here. Okay, and let me add the index also. Yeah. Right, these are your index. Now you have another data frame. Right, so you can see here there is we cannot, I mean, the idea is none of the columns can be used to merge it, but we want to merge it based on index. Okay, based on index, like index can be your author ID or something like that. We want to merge it based on index. So what you can do is df1 dot join df2. df2. Okay. Oh, I didn't set. Hey, what? Oh, df, not df1, right? I want to join these two guys, df and df2. Okay, so you join, right? You can see this here, adding more columns here, and it is joining based on index. So the three different, one is concat, combining different data frame by row wise, column wise, and all that. Second, specific type of merge, to do database wise merging, inner join, left outer join, outer join. You can do all those varieties. If you use a column, you can use many to many join, many to one join. I'll show one example of many to many joins, so many to one joins. And okay, and the third one is this guy, where you are actually joining based on index. Right, these are the three varieties. So let me just show one many to many join. So we have, let's see, you have df1. So so let me have a df3, df4, pd dot data frame. One, two. B df4. Alright, so if I do df1 merge df4, yeah, that's something wrong here. Oh, sorry. df1. Oh, right. Both the column names are same, right? On A. You can see here what happened. Okay, so here both the column names were same, right? Both of them had A and B, right? So what happened? A was you were anyway joining based on A, so B from this is from first column, this is from second column. Not right. So that is how you would differentiate.
So the df1.
Okay. This is df4.
It's a kind of wheel problem. It's kind of wheel problem.
Kind of?
Wheel problem.
Wheel.
In Excel we are wheel problem.
Oh, I am not much aware of that.
All these things are copied from Excel only. Somebody was doing manually, now they are trying to reflect it in a comfortable way.
Absolutely.
Someone doesn't like Excel anymore.
Excel does not scale. Excel is not programmable much, right? You can.
Microsoft might come up with some new idea.
They are already. I heard recently they are planning to buy GitHub.
Yeah. $2 billion.
Yeah. So you can see here. Here you have df1 and see df1 had a few one repeated twice, right? And df4 has one only once. When you merge this one 33 gets repeated twice. Okay, this is what your this is one to many. Of course, you can do many to many also in the same way, seamlessly. Okay, so we'll use this when you're dealing with sales data and all that. Okay, so these are your join operations. Now, okay. Okay, so after join operations, we'll go, let me see. We have this data. There are a few functions actually. After functions in the sense you have apply, map, and map. 3 utilities. Okay, so let's see what is apply first. This is kind of very important for any let me do this data. PD dot data frame A 1 2 3 4 5. Six, 7, 8, 9. Suppose you have a data frame like this, huh? Now, if I ask you, you have to do a sum of all the values across each column. Okay, or maybe sum of all the values across each row. Okay, or maybe if I ask you to create a new column which has maximum of these two columns, like the new column, actually I have to create a little heterogeneous information, right? You have to create a new column C which has maximum of these two values. Understood, right? Okay, so we have to do such things where your operation might span across multiple rows, multiple data, multiple columns. Okay, so for that you have a function apply. Okay, in apply, there are two ways. One is here you can actually pass x is 0 or x is 1. Okay, x is 0 is which dimension is x is 0? Hmm? Y axis is 0, right? And x axis is 0. So let's see here what happens. So first you have to
X is 0 is column, X is 1 is 0.
Right. Okay, so if we are passing a function here, this function takes a right. So what it did, this is the column data that it got. Okay, but you can see here sum of all the data across column A is 62. Right, apply F. This means by default it is x is 0. Right, it is taking all the sum of it. You just change it to this. This is what sum of values along x is 0, x is 1, row wise. Right. Okay, so this, if you see the data earlier, okay, so what is this? 17 is 11 plus 6. Okay, so when you do apply and function, this is the function that you're passing here. Like in Python, you might have seen, you can pass a lambda also. Okay, the function you're passing here. This function, what is the data that it takes? The data gets when you use x is 0 is all the values along this. When you give x is 0, it gets all the value along this. Makes sense, right?
When you're saying like C dot sum, the data type for C is data frame. When you are saying like C dot sum, what is C? Is that a
C is series actually. See, when you do this, when you access data along the column, what does each column mean? Each column is a series. Series. You do df.a, that is a series. That's what we discussed last time, right? df.a is series. Okay, df.b
is a data type also.
Column type. Okay, so that's the whole reason.
So if I want to store that values in a different column,
that is also easy. So say for example the sum, right? You want to return the sum to a different column. You can do this. Same ABC. Got it, right? Let's write an okay. Now there is this. Suppose I have to do some changes here so that I get the maximum of these two values. What do I change? Max function, right? I can independently write. Got it, right? It starts.
Just add another column.
So, oh, it is taking, that's what, right? It is taking all the three things now. It is taking all of them. Did you get it? Why this is happening?
Yeah.
I did it. Yeah. So it is taking all of them now.
Yeah.
Okay. So now I mean that's what it is finding max of all of them. Right. If you want to do again sum, it will return a new column. All the columns, it will combine data this way, right? That's the reason. Right. It is giving you sum of all of them. Right. Now if I do max of it, or say min of it. Okay, so this is when you have data frames, like each column is a sales information. You have to find what is it, when what is the maximum sale, average sale, mean of it. Right, you can find mean of it. Do all this operation. And sometimes if I ask you now this question, you have to find between A and between A and B, which was the highest. Now I'm doing all of them. I want to ask you. Okay, you have to go for A and B for that part. How do you do that? Yeah, you have to specify the columns. How do you do that is you want to compare between C, A, if
Let's see.
what happens after A, G?
So what does it mean if C of A is greater than C of B? Like the values, right? But all the values will not be greater than right?
Oh, I forgot returning.
Return.
Yeah, I think that is this guy will do. Got it, right?
No.
Take 10.
Can you explain it again? What is it? The 107?
So in this line, what it is doing is it's just here you're passing this function f and you're doing this access1, right? So it means you're accessing row wise, right? Each row it is taking then this is a series here. Remember, you can access values of series by index. Okay, you can access values of series by index. So CA, you are returning. CA, you are getting the 8th value, this 11. CB, you are getting 6th value, and it is trying to find whether A is 11 is greater than 6. If so, return that, otherwise return this.
Return what?
Return this function will return, so it will create a new data frame, new column G.
Okay.
This is G.
Okay, so whichever is greater, it will return the.
Make sense?
Yeah.
Okay,
basic.
Absolutely. So now
nothing to break your head on this.
Okay. So the data frame is there. Okay, now a little bit of dealing with unstructured data. Okay, suppose you have each column contains list of information. Okay, you have to convert that into a table. Okay, so let's see now. Data. Okay, so let's say this is one column. Did you see this data? it would come as a kind of unstructured data, or I can have a JSON content also here. Okay. Okay, this is the DF. Okay, so you have this. Now what you want to do, you want to convert this into a tabular format. This is unstructured data. And to convert this into tabular format, 153 will be in one column, 264 will be in one column. That way. Okay. Now can you try guessing how do you do that with apply?
Should we use the function?
Apply.
Write the function.
How do you break it down to different columns?
Sure.
Anything that rings a bell?
So split is there. Is there something that
Huh?
is there some operation called split?
But it will convert string into list. I want different columns here. Okay, so what will this return? This will return 0, 1, 2, 3, right? Okay, so df a plus I. Or maybe I just simply do this. AI df dot apply. Okay, you have this df apply, and in df apply, okay, you pass this function f.
So it should be range of A or range of 4?
Array 4, because 4 columns are there. As of now, let's start 4. Maybe, I'll first show one link, then I'll generalize it. Okay, so df df dot apply. Okay, I'll show for one data. Then you have this function. Return 0. Right? Sorry. It's right only. No. Return. Yeah. So right. So here you can see it is returning 0 0 first column. This is the first column. 0th column. This is 2 6 4. Got it, right? Okay. So break it down into pieces. Wherever you have unstructured data, right, you have to deal with it. Break it down into pieces because it is bracket, right? R 0 0 should be.
Yeah.
Okay, so if you have to generalize it like every time is it clear? Right, so what you can do is df. Now you do df. You'll have one column here. Okay, this was dealing with unstructured data if it is in a list format. Okay, depends on how it varies, you can vary it. You can do the same for dictionary also, but that would be an assignment. If your content is JSON, right, or a dictionary, like A will contain a dictionary here, which contains two data, A and B. So this is how the data frame would be looking like. You have to find a way to, suppose this is the data frame, huh? Huh? No. Just a second. See, this is your A column. This is your B column. So that will be the case. Suppose your data frame is like this. You have to, the resultant should be a new column A and B. A should contain 1 and 2. Understood, right? Alright, right? This should result into the output should be something like this. A column should be having, right. This should be the output. deal with it. Now you understood apply. Now I'm going for more generic things, that is map. Okay. Say you have a data frame this Titanic data. What you want to do? You want to from the age column you can see different ages are there. Okay. First, basically you want to remove all the data. You remember we had this info, and we can see that there are some data for which age is missing. Right? We want to remove all the data from which age is missing. Age. Not. This is the this is the data frame in which all ages are present. All the ages present. Got it? Not null. DF. Now, okay, when you have this DF, okay, the next thing is you want to find out there are these ages that you see here, right? You want to create a new column for where the age is less than 18, we'll mark it as kid. Age is greater than 18, we'll mark it as adult. Understood, right? Okay, so they do this column-wise operation. You will find there's a utility map, which makes it very simple. Okay, so map also here. You can write a lambda function. Kid. If x this returns a new series here. This is a new column. You want to add a new. And this is how you are adding a new data frame column. So, what is key.adult segmentation? Age segment. Right. So after that you mentioned DF. You can see one age segment here. Got it, right? Did I write reverse? Oh. Sorry.
Yes.
Right. This is map utility. The third one is, and last in the list, is apply map. Suppose you have a data frame. This one. You have a data frame, DF1. What you want to do is you want to add, like this is students' marks. Okay, this is students' marks. There was some wrong question in the exam. So now you have to add 5 to everybody. Okay, so you can do that with apply map. Entire data. Lambda x. Clear?
It's written both the columns.
Huh?
Both the columns.
All the data. Okay, that is apply map.
So if I have to apply for only one column,
Then
this says that.
then you use map, right? Then you use map.
Apply map, right? Like if I want to
Do this, right?
add 5.
Only one column.
So usually till now, like what we have covered is like if it is column name, we used to specify inside that operation, right? So here we are specifying it outside. So is it like when we are performing any operation on a column, so can we specify like this? Just directly.
Yeah. So whenever you're dealing with columns and doing a mapping, converting data from one format to another format, you can use map. Apply is for column row, very generic function, right? Here you have a more like you have this df1 dot aggregate, okay, which is like a right. I mean, you can mention here which say a column is there, right? It will actually sum all the values corresponding to a column aggregation.
Yeah.
Okay, and so B column you want mean. Okay, it's getting a mean. Okay. Okay. Now one more thing. So okay, so we had this. Right. So now we'll play with strings. Pandas provide this special ability to deal with strings. Okay. So name column is a string column, right? This is string column, right? On top of it, if you want to do some, you get the str dot. You'll get all the string related functions. For example, you want to find out, you want to capitalize all the data. Two of us. Right? It is actually upper. All the things like, if you, after this, if you want to actually split, right, it will actually convert the entire name into lists like this. And from there you can extract the first name, last name, or whatever you want, right? Then you have count. Counting for a special A character, it will tell you how many times A is appearing here. Got it, right? It's returning a series here. You can map it to a particular, and if you want how long the length, right? This is the length of the name. Okay. Yeah, so let me just talk a little bit about, now we did done with this part. We'll talk a little bit about hypothesis testing. Okay, there are a few more things we have to do in Pandas. Okay, I would want you to practice all this. So all these things are there in the notes. Yesterday, that is what I was showing you, right? So all the things are there here. Okay, you can, some things will be additional, but apart from that, you can actually, apart from handling missing data and rolling by, which is like half an hour stuff. Okay, I've done almost, I'll do some projects also, small projects using this so that you're comfortable. I know, a lot of things are there, right? So we'll do some small projects, and with this, I mean, what you can do is you can try writing all the code that is written. That way it will be like it. So that's why I'm taking simple use cases and trying to explain the concept so that you can understand what is happening. Okay. 1 minute. Break. That's okay. No, you need it. Just 2 minutes. I'll just gum out. I'll not take more than that. Okay. Just let's washroom break 2 minutes.
Not the tea break, it's tea.
Is this video, the recording was shared for last class?
Last class.
Yeah, last week.
Number.
Yeah, number I have got it. So for the next class and yesterday's class was the recording.
No.
I have not seen the recording.
Stacks and Panda means it is yesterday's to yesterday. Sorry, used to previous
Yeah.
class. And number is previous to previous.
Yeah,
And last
yesterday's.
yesterday's class I have not seen.
What is the subject line is
It's Stacks and Pandas 1 and number complete. So during
hey, I did not receive. Like, what's the email ID which you received from?
your email ID is Gmail.
Yeah.
You check the value is
No, from which email ID do we get the email?
that's
Okay, yesterday. Yeah, he has shared the link, right? YouTube link, 2 links. So that is the first, class 1 and 2. Class 3.
Yes, shared 2 times.
Yeah. Yeah.
I don't know how he is able to create this link. Is it great substance?
Just upload it.
Yeah. They could make it interesting if they will use the resources in building some project, but that is the most difficult one. Not project, I call it as a product.
Product, yeah.
Converting the ideas into a product which to touch,
I guess that we'll be doing it after we learn.
I mean, see,
That's what he said.
something is systematic, and actually, we are believing we will be able to grasp that particular thing, challenge for people. Then it creates sense. Doing something like, okay, yellow taxi project. Okay, these crores of people are doing the same thing only, sold in market. But yes, something is not, we are not able to fix it. Like what I do is, I just pick challenges of my office. This is what people probably clearly.
I guess we can do it so we can see the next time coming with an idea we can start.
During Pandas we can do, but for data science, you have to first learn and not.
Exactly. Yeah.
I think you can easily find a clear job once you do this kind of stuff if you go into process.
Yeah.
If you already have an upper hand, then you'll enjoy your masters. Why don't you go it for more technical? Why business analytics? Why don't you take it like data science?
No. Like, let me see, like, how I guess, like, towards the end of the program, I can judge, like, whether I'm really a fit to data science job. So, in that case, yes, I'll be good.
Okay, now you have both the options open.
Yeah, with this, like, we have the jobs profiles are open for data scientists, business analyst, data engineer. We have
with business analytics?
yeah, with this.
That is good, right?
Yeah, so the field is It's last, so yeah, let's see how it goes.
The term business analytics is same as machine learning.
A huge overlap. There are some unique things as well.
Data science is an umbrella, and business analytics comes under that. Like,
Yeah, that's a part of it which has a lot of business.
Exactly.
No, as in data science, you do it for business only. I mean, in general. Okay, of course, technical things is different, scientific things is different. In general, data science is for business only.
No, you can do for charity also.
You can do it for charity also.
And let me know if anybody is interested. I mean, especially there is one thing I am working currently. There are some biologists that I spoke long time back. I am not in touch with them now. So they were working on finding polymer eating bacteria.
Polymer eating bacteria.
So that the plastic pollution can be finished.
Okay.
So this was a charity project. I started working, but those people actually left country, and I'm not in touch with them anymore. Okay, so I want to initiate that again. Okay. Okay, but of course, no money involved here. It's a pure research work. Okay, so that's the whole thing. So this was for a cause. I mean, there are a lot of NGOs, a lot of you already know that. I'll be recording this. Pause recording.